Now that the FE model is thoroughly broken by Will Duffy and the final experiment, I guess I just had to go back to normal everyday observations. So when Ruhif posted this video yesterday, I thought, yes, I'm back. For now at least. These observations are fewer and far apart. So let's see what's going to happen. Anywho, he posted this video where an observation is from Mauritius to Reunion. And he found the height of these mountains. I also included this one, I'm not going to pronounce this, in my video. I found the height on it on Wikipedia. Roof has done quite some job here, so I'm just gonna do the sloppy seconds or just finalize it. He didn't have the location of the observer, but I found that. I went to the social media platform formerly known as Twitter and actually found this here from Bertie Makuna, who did the observation. It said his observation height was about 146 meters. And it's done here by the Cascavel shopping mall on Mauritius. So I found that, the shopping mall and the road there. This is most likely where the observation is from. That conforms with the map and the arrows there. And this is about 144, 145 meters. And he is looking in that direction towards Reunion. I thought it was funny here, because you see these lines. They are going to the ocean. And then they're curving over the curvature of the earth. And then going back up the mountain on the other side. I found this quite hilarious actually when I saw it. So over on Mauritius, sorry, the Reunion here, we have these mountains. Again, I'm not going to pronounce them. And as I said, I also included this one, just for shits and giggles. And that brings us back to my trusty old reality check model. I have all the distances here from the observer to the top of these mountains. And all the mountains are over here with correct height. This is a 1-to-1 scale model. So let's see how this appears on the flat Earth. Let's place this guy here. Enter P900 mode. And there we are. So on a flat Earth, this should be mountainous. Yeah. Sorry. You should see all of them tall and nice, and you should be looking upwards toward them. Not much, but 0.94 degrees. So there should be nothing covering the bottom of those mountains. If we now go to the globe Earth, here. Uh-oh, that doesn't match. We have the further left one and these two, but there are something missing here. We can't have that, can't we? Let's try, this is over the ocean, with a hint of some refraction here. The standard refraction model. Let's put this guy down here. And there we are. Now that matches pretty damn well. Let's go back to the observation. We have this one here. This one is just a little bit higher than this one, and this one is just a bit lower than that one. Yeah, that doesn't seem too bad. So refraction is a thing, and in this case it only needs light only needs to bend like 1 degree. This is actually over 2 degrees of curvature. You can see the halfway point here on the globe and here with the fractal model. But you only need to bend the light just about 1 degree over that horizon from this to work properly. On the flat Earth, you need to bend the light a whole lot more in the wrong direction. Let's see here. I have the microphone just above the keyboard, so. Here you have to look up just, I said 0.9, it's 0.61, sorry. This is how you have to look upwards toward the top of that mountain. Now, just to make it clear, we can't tell if he's looking upwards or downwards here because we don't know how the camera is tilted. There is no point of reference here. So if he's tilted the camera just a little bit down, this can be anywhere. So we don't know if he's looking up or down towards those mountains. Just to make it clear. If he's looking up or down here or here, I'm not going to claim anything about that. I'm just going to see what fits best in the observation. And on the flat Earth, we can see all of the mountains. We don't do that in observation. We see just the top of the smaller ones. Let's go back here. Here. So if this one is down here or up there because of the camera tilting, we don't know. But this matches the observation, and that's the glow model with a hint of refraction. I saw this comment here on one of the replies to that on the social media platform formerly known as Twitter. And using Pythagorean math, yeah. It's 8 inches per mile square or something. You have 2.47 miles of drop is missing. Yeah, this is bullshit. So on the here, I had from ground level, just had a line, this one, pointed straight out as a tangent from here. Now this is 146 meter here, 146. So from the ground, of course you're gonna have a drop out there, and at that distance, that is 3,700 meters of drop. That's not how you measure either curvature or obstructed height. That's just a drop. That means absolutely nothing, because when you have from here 146 meters up, that drop is over here. We see over the horizon down there. Yeah, 8 inches per mile squared. Doesn't include observer height, sorry. So again, yeah, the globe Earth model with just a hint of refraction. This fits damn well close to that. Just saying. Yeah, I guess observations now will be what I do probably. Well, let's see. Thank you so much for watching. See you next time. Bye-bye.